miscellaneous exercise 10th problem. So this time we'll be continuing with the 11th problem. In the miscellaneous exercise we've got all the problems which are mixed. So we have to look at the problem and classify as to which type it belongs to, and then accordingly we can use that particular type of differentiation and go about doing it. Like for example, here the 11th problem, they give us the function x raised to x squared minus 3 plus x minus 3 raised to x squared. Function raised to a function, whenever it is given, it's always an example of logarithmic differentiation. So we have to do logarithmic differentiation. That's clear. But still, there is another hassle over here, that generally children tend to take logarithm on both sides and then do differentiation. That will go wrong. Taking logarithm on both sides and then doing differentiation will work only when there is a single term. Now here there are two terms. When there are two terms given here, that method doesn't work. So what you have to do is, you have to assume the first part as a different function u, second part as a different function v, get them differentiate, get them to take, you take their logarithms and then get the differential and then so on. That's how you'll be able to get the derivative of this entire function. So that's how it is. So it's a common error that we can find in the exams, that children generally they take logarithm on both sides and then they go on to differentiate. Then that will go wrong. That will not be correct. You'll have to do it this way. You have to take the differentials separately, call u, call v, and then that's how you're going to go about doing it. Let's get started. Let's call this function as u. Let the first part be u is x raised to x squared minus 3, and let this part be v, and that will be x minus 3 raised to x squared. We'll take log on both sides, so this will become, take gradually, first we'll take log u, so that becomes log x raised to x squared minus 3. We all know that log a raised to m is always m log a. So by that approach, this becomes x squared minus 3 into log x. So also this is log u. Since we know we require the du by dx, let's get the differential also and keep it ready. So taking the derivatives on both sides, let's see what comes. So let's take the derivative of this. Log u, the derivative will be 1 by u du by dx. The derivative of this, it's a product, so we apply product rule. We all know product rule, u into v is u into derivative of v plus v into derivative of u. So first we will keep x squared minus 3 as it is. We will take the derivative of log x. So also let's keep log x as it is and take the derivative of x squared minus 3. So what comes? We'll check over here. It will be x squared minus 3. Derivative of log x we all know is 1 by x. So also log x as it is, derivative of x squared minus 3 is derivative of x squared and derivative of 3. A derivative of x squared is 2x. Derivative of 3, because it's a number, there's no derivative. So let's see now what comes. This is 1 by u du by dx. So what is du by dx for us? Du by dx is u times, the u has to go there, and you'll get x squared minus 3 by x plus 2x log x. This is our du by dx. Let it be there. We'll use it when we require. And then we can move to the v part. V is still pending. So let's see how to do the v. Same thing. We'll take v, we'll take the log on both sides, then we'll take the derivative, and then we'll use it as it is required. So let's take the v. So since v is like this, let's have it let's continue from here. Here we have v as x minus 3 raised to x squared. So we are taking the log on both sides. Log v equal to log x minus 3 raised to x squared. We all know that exponent comes on this side. So x squared into log of x minus 3. Now this is a product rule. We know we will take the derivative, and if we are planning to take the derivative, then it will go by product rule. So let's take the, now see we have taken the log. Our idea, our final aim is to take the derivative. So now we are going for the derivative step. Taking derivatives on both sides now. We know we have to take the derivative, but because it's a function raised to function, things are very difficult. So in order to make the whole thing little less complicated, we have taken the log and then we are taking the derivative. Our final intention is to get the derivative. So that's what we're going to do now. So what we are going to do now, on both sides we are going to take the derivative. So this is going to be derivative of log b is 1 by b dv by dx. This being the product rule, x squared will take the derivative of log x minus 3 plus log x minus 3 as it is derivative of x squared. Let's see how it goes. So this will be of course as it is dv by dx, and this is now x squared. Derivative of log, always linear functions, they behave like x itself. So log x, we know the derivative is 1 by x. So also log x minus 3, because it's linear, x raised to 1, no? This is x raised to 1. It's a linear function. Linear function behaves like x itself. So log of x minus 3 is going to be 1 by x minus 3, just like x. You know, all linear functions you can treat as how you treat your x. So had it been log x, it would have been 1 by x derivative. So though it is log x minus 3, derivative is 1 by x minus 3. Now here, log x minus 3, derivative of x squared we all know is 2x. So that way, let's check what is our dv by dx. Our dv by dx is v times, we can go on the other side, x squared by x minus 3 plus 2x times log x minus 3. That is our dv by dx. You shouldn't get tired at this step now. Many a times it so happens that by the time this is over, you're a little exhausted and you forget that you have to get dy by dx. That should not be the case. You have to get back and get the dy by dx. We know our final intention is to get the dy by dx. So let's get the dy by dx. How is the dy by dx? Therefore, dy by dx, we all know, since y actually is u plus v. That's how we have assumed. No? Since y is u plus v, so dy by dx logically is du by dx plus dv by dx. And we have both these ready with us. So it's quite easy. Du by dx is this term. 1 and 2 you can use. U, we cannot write u because that's our creation. So we'll get back x raised to x squared minus 3 times x squared minus 3 by x plus 2x log x plus the v, this part. So v for us, v for us is x minus 3 raised to x squared times x squared by x minus 3 plus 2x log x minus 3. Just check how this goes and let's see how the whole thing happens. Yes, that's how things work out, and that is going to be our solution for problem number 11. The next problem, since it's bit voluminous, so we can have the next video for the next problem. Thank you.